Let's graph the function f of x is equal to 2x squared plus 4x plus 5. So we've learned to gather different information. So one of them is the y-intercept. To find the y-intercept, we're going to let x equal to 0 and solve for y. If x is equal to 0, this would be 0, this will be 0, and I find my y-intercept is at 0, 5. So I'm going to plot that point. If we want to find x-intercepts, one of the things we can try to do is to factor our quadratic, but we're going to find that this is actually prime and not factorable. So we're not able to find our x-intercept in that manner. Now let's see if we can find our vertex by completing the square. So in other words, we have f of x is equal to 2x squared plus 4x. Remember, we want to kind of have this by itself, and then I have my plus 5. Because I have a 2 in front of my x squared, I'm going to GCF the 2 and have x squared plus 2x. Notice I left some space, and then I have plus 5. So in here, I want to complete the square. So half of 2 is 1. 1 squared is 1. So I'm going to add 1 here. Remember, when we want to get back to our original equation, we would multiply 2 times x squared to get our 2x squared, 2 times 2x, and that will give us our 4x, and then 2 times the 1, and that's going to give us 2. So if we add 2, then we need to make sure that we subtract 2. So that way our equation stays the same in terms of value. Continuing on our completing the square, we're going to get 2. This becomes x plus 1 squared, and on the outside I get plus 3. This is my equation in graphing form or vertex form, because I can quickly find that the vertex is equal to -1, 3. Remember, on the inside I solve for x, and that's how I get x is equal to -1, and on the outside it's a positive 3. This also tells me that the axis of symmetry is going to be the equation of x is equal to -1. So if I come to my graph at x is equal to -1, and I'm just going to put a little dash right here, this is what we would call the axis of symmetry. So some of my parabola will be on the right side and some of my parabola will be on the left. And my vertex will be right on my axis of symmetry at -1, positive 3. So now let's take a look at what happens when we have that 2. So we've already seen that the vertex has been moved to -1, positive 3. And then we also see that we have a vertical stretch. So that means we get our y values and we multiply them times 2. So our parent function of x squared had the values of 0, 0, 1, 1, 2, 4, 3, 9. So now this 2 is going to multiply these guys by 2. So we're going to see that we're going to have 0, 0, and then 1, 2, and 2, 8, and 3, 18. So remember, I'm multiplying this times 2, and that's how we're getting those numbers. So what does that mean in terms of my graph? That means that when I come to my vertex, I go over 1 and up 2. I go over 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, that's all that's going to fit on terms of my graph. We need to remember that's going to be half of our parabola. And on the other side, it's going to be its mirror image, because the axis of symmetry says it's going to be symmetrical. So we go over 2 and up 8. So notice we find that there are no x-intercepts. We can see that from our graph, and we suspected that when we could not factor our equation. In this case, we used our transformations in order to graph our parabola. That concludes this video.